Good evening, all, and welcome to the very last of our lectures together, not only in our distance learning odyssey, but also for the semester. It has flown by, and this is kind of how we're going to wrap it up. So tonight we're talking about the philosophy of psychology and also the mind. Up until about the 1940s or 1950s, depending on where you were, a lot of philosophy departments shared their space with psychology departments because the two disciplines are so close to one another. A lot of what we do has a lot of overlap just in thinking about how we think and so on. But at least 3 times in the 20th century, psychology has kind of settled on its subject matter only to change and then adapt another picture of reality. And so it's kind of struggled to get some identity of what it itself is. Now, psychology laboratories don't appear that much later than laboratories in other disciplines. Chemistry laboratories are in universities in England and the United States really no earlier than about 1830 or so. And so these non-academic settings are really kind of starting in about the 18th century and then really picking up rather rapidly. So psychology is kind of this hybrid science because it deals with things that are both scientific traditionally, but also humanistic. And one of those things that it's really struggling for is to try and get that unity and that disciplinary coherence. That is, that enough folks agree over a broad enough swath what it is, what it ought to talk about, and so on. And so how are we going to do this? Well, we've got to create some kind of order and system, but it's also going to be sort of arbitrary. But they're also necessary, else there wouldn't be any subject to study at all. So the starting point then is kind of to identify what is psychology about? That is, what do its practitioners identify as good for having the discipline? What would other reasonably informed persons expect from this discipline? So our Oxford English Dictionary definition, which I generally encourage you not to use for term papers, defines psychology as the study of the human soul or mind, a treatise on or system of this. And that's not a particularly helpful definition because it really just doesn't tell us enough. Maybe a better way to look at what psychology is would be to look at some major 4-year university, perhaps a school known for its psychology program, and look at what are the offered courses, what are the assigned texts, in those major departments of psychology. And a lot of these we're going to find to be highly particularized. That is to say, they're going to have criminal psychology, abnormal psychology, child psychology, developmental psychology, all of these very different specialized fields. Excuse me. If we go all the way back to Aristotle, Aristotle first used the term psyche in his treatise on subject to mean the first principle of living things. That is, what is psychic then is this complex process. It's not a thing that occupies a space and has some existence outside the creature that's animated. This animating principle, this power, is expressed in various ways, and this is what gives living things their life. If we fast forward to the 17th century, we see Descartes, we see Locke, and they're taking kind of a more daring approach to these ideas. What they have in common is this idea that fundamental questions in philosophy are going to require some sort of systematic treatment of psychological states as well as processes. Locke and Descartes are virtually inventing psychology as they go along. It's an independent field of inquiry. It's something that they're developing through systematic observation. One of the ways that we think about this is by analyzing our patterns of thought. So imagine, for instance, that you have to build a table. I use that example because I am, in fact, building a new dining room table. And questions that you have to look at is, how frequently will we eat at this table? How many people will we reasonably expect it to seat? How much lumber and material is this going together? And that thought process that guides us through that, for me, might be different because my dining room is huge. For someone who has a tiny dining room, as I used to have, it's going to be a much different question and a much different approach to the process overall. And so we look at these patterns of thought as really pretty indicative of how we go through things. But it's really not until the 20th century that we start seeing cogent arguments against philosophizing psychology become what we will call scientific psychology. So in the early 20th century, America had Dr. John B. Watson, not the one that hung out with Sherlock Holmes, but a different one. And he's arguing for abandoning kind of all these other approaches to psychology and saying the only possible way that we can reach this is through introspection. What Watson is insisting on is that for something to be scientific, for it to have a scientific status to it, it has to be public, it has to be observable, and it has to be measurable. Now, there's a lot of implications that are heavy in this. Public means one other person at least has to be present. Observable, it has to be something that we can actually see, that we can participate in empirically. We see it, we taste it, we touch it, we hear it, we smell it, and so on. And then it has to be measurable. And this last one is especially tricky. I mean, we think of typical measurements in, pounds and inches and liters and all this kind of thing. But this is going to be a little more complex than that, because how do you measure psychic phenomena? That is, how do you set a standard and then see whether someone is above or below that particular standard that you've set? Because for all things psychological, then, we've got to turn this into behavioral terms and observations. How is that going to take place? A guy comes along named B.F. Skinner. In the 1960s, a lot of psychology departments had really started to think of themselves as behavioral science departments. Behaviorism gives this purely descriptive science that's really kind of independent of what's going on in your brain itself. And the project of predicting and controlling behavior really requires no support and doesn't accept any challenge from biology. Given this approach, we kind of see a resistance and criticism starting to become possible. Psychologists trained in neuropsychology and physiological psychology, so looking at stuff that's actually going on in the brain chemically, electrically, and so on, weren't aware yet that a lot of this behavior that we exhibit depends on biochemistry and electrophysiology in the nervous system. They're not prepared to give up some of the stuff that they've worked towards this. Studies of animal behavior show up, and in a 1948 article titled Cognitive Maps in Rats and Men, a guy named E.C. Tolman summarized all of these studies saying, it's about the cognitive nature of problem solving. So kind of if we go back to the Turing test and I were to ask you the best way to get from here to Austin, it's really going to depend a lot on how you view that. Do you want to go the most scenic route, the quickest route, the fastest, and so on and so forth, the one with the most amenities and on. If we take this together with what's called a Gestalt theory in psychology, this is going to require us preserving the mental aspects of things. We've referred to Gestalt sometimes. It comes from the German. It means like shape or form. That the central principle of this is that the mind itself forms a global whole with self-organizing tendencies. What that means is this. So we know that there are certain parts of our brain that handle, say, our visualization of the alphabet or our organization of street signs, what they mean, what they indicate, what they caution, and so forth. But we don't really think about it in those terms. That is, if I come upon a street sign, I go, wait a minute, red octagon with white writing on it. I don't have to file that away in that particular part of the brain. It's just the brain as a whole comes up with what I need to know to stop in that context. So the whole is greater than the sum of its parts is really what this Gestalt is getting at. The means by which we can commit this is kind of experimental though, but it's got a whole lot of baggage that comes along with it. First, we've got to get some kind of response indicator. We're going to take the observed behavior of our research subject, and we're going to find some way to indicate that they've positively received a given stimulus. So if we reward them somehow, or if we punish them somehow, you could have a little button that gives you a shock if you give the right answer, or something that, releases endorphins or gives you a smiley face if you get the right one, okay? These response indicators, we're going to sample these repeatedly. And that's going to give us a data set. We're going to analyze that. We're going to determine its validity. And we're going to try and control all of the stimuli that we possibly can. That is, individual stimulus types of things. We want to make sure that they're not interfering with our experiment. Now, there's two possible questions that come from this approach. One, to what extent is such an idealized context representative of the actual world and actual life? That's a real big problem. So you may have participated in psychological studies before, but how much like the real world are they actually representing? And then the second question is, do we find in these experiments how people actually solve problems and comprehend stimuli? Or are we just calling on subjects to respond as they would see the world if the experimenter would like to have it seen. So are they making it up to please us? And we can highlight this problem of validity by thinking about a frequently studied phenomena in psychology, emotion, okay? Attempts to predict and control behavior or model psychological life via examination of the emotions in the context of laboratory research really is kind of ultimately useless in real world practical applications. On top of this, we got to start thinking of, do these statistical modes of analysis, if we're looking at something so complex, are we looking at the analysis of variance? An analysis of variance would be like this. We're going to identify the separate influences of several variables on the event or the effect study, and see how that works. So let us say, for instance, that a light is on in a room. We're going to look, are the switches up? Are the windows open? Are the doors open? Are there people in the room? All of these different variances, and we're going to try and eliminate those and figure out which one is actually causal, the switch being up. Okay. Analysis of variance might actually describe or even identify the effects of those variables on no one in particular within the sample subject, which doesn't tell us a whole lot. And so the ultimate question here isn't not whether this is the right approach, but whether this is essentially what we would call nomothetic or idiographic. Something is nomothetic if it looks, remember, nomos is law, if it looks for general laws, kind of describing the trends and the regularities in the data set. Something is idiographic, idio, picture, graphic, to write out or to draw. It's sensitive to the unique and individualized nature of perception, comprehension, and adjustments to the surrounding world. So if I watch a movie and I really enjoy it, and you watch the same movie and you don't really enjoy it, that would be closer to an idiographic type of experience, because there's something about my unique experience of it that I get enjoyment from it. And for whatever reason, you don't. And that's going to differ along the lines. Now, generally, we would assume this nomothetic approach would have to use really large samples to get general laws. But in basic research, a single observation can sometimes reveal a general law. If I were to toss something to you or at you, your instincts are going to tell you to either try and catch it, try and bat it away, or try and move yourself entirely to avoid it, okay? That's going to give me a pretty good and fairly reliable general law right there. Now, if something wants to be thought of as scientific, another set of questions really has to show up as to what the proper model or template would be like, because science itself isn't singularly committed in this regard. That is, it varies depending on whether we're talking about chemistry, psychology, biology, physics, and so on. But being not really a physical science and not really a biological science in the strict sense, psychology has evolved as something as almost like an engineering science is what we would say. And what we try and do in engineering science is reduce the problem to a model. That is, break it down to something that is fairly ideal, but also fairly straightforward and simple. And we're looking at function, and we're looking at the means by which these functions take place and are integrated into overall performance. So psychology attempts to use the laboratory context as a simplified model, and then take those experimental variables to tap into one or another functional model from there. Okay. Maybe the most successful application of this line of thinking we'd see in contemporary cognitive neuroscience. Any cognitive achievement, no matter how complex, is reducible to an ensemble of distinguishable functions. That is, if you think of the last book you read, okay, and you plot the character progression or the story arc or whatever it may be through that book, all of that stuff can be broken down to distinguishable functions. Story arcs, problems, and so on. Each function is accomplished by processes, networks in the central nervous system. Manipulation of these relevant variables in the controlled conditions of laboratory research, this is a way to put this on some kind of foundation. We could say, do all books in this category, say science fiction or horror or thrillers or whatever, do they follow some very basic pattern? And yes, they probably all do. So it doesn't take much by way of objective distance to see that entire undertaking rests on confusions, even mistakes. It's important to understand the difference between an engineering module that really performs a task and a cognitive event subject to interpretation. So there's a lot of attention paid in this psychology to the analysis of language, why we would use some words over other, how does tone of voice, how does cadence, how do these things change? But not a whole lot of attention is paid to the productive use and constitutive power of language. So maybe we step back and we examine those methods. And one of the ways that we do that is we look at philosophy of mind. Okay, so now we're shifting gears somewhat. Descartes had that really sharp distinction he drew between himself as a thinking thing, that is a res cogitans, and an extended or bodily thing, a res extensa. Okay? And this got him criticized by folks like Hobbes and Gassendi, but both would have agreed that a broad scientific perspective, according to which these physical sciences are said to be complete, nothing in the domain of really real falls outside real physical, that is a physics. In other words, reality is not composed of two different kinds of stuff, but one kind, the physical. And that would include all of those things that we consider as mental. Now, this position is called ontological monism, one, okay, and stands in opposition to ontological dualism, which would say two. Okay. For the monist, there's only one kind of furniture in reality, and that's physical. For the dualist, there are two. The dualist is going to add the mental to the physical. If the latter position were correct, that is, if the dualists were right, it's argued that physics would be incomplete because the laws and principles don't account for this other immaterial, non-physical aspect of reality. And they might be right. The ontological monists, they can retain certain mentalist terms and concepts as kind of this folk psychology. But for practical purposes, it would be very, very difficult to take this out too far. A guy named Donald Davidson dubbed the use of this anomalous monism. So it's anomalous, meaning it doesn't happen a whole lot. It's just a weird blip on the radar. Okay? Our mental terms and our concepts can't really be reduced to physical events and processes, at least not reliably. The position then that we take on the mind-body problem is either going to implicitly or explicitly inform the positions we take on a far wider range of things within philosophy of mind. One of these problems is a problem of what we would call representation. That's a central part of the problem of knowledge. It's an enduring issue in the problem of mind. At the most fundamental ontological level, our experiences of the external world are really complex arrangements of matter and energy. Their matter, our matter, energy, and interacting with them. So we might look at, I was sitting out in my garden this morning, and honeybees are all over the flowers. It's cool. Honeybees, their vision is sensitive to an electromagnetic spectrum that we're blind to. We simply can't see it. Does their vision of the lilies and the roses and so on more accurately represent those lilies and roses than my visual representation of them? This is difficult. So the question of representation is kind of restated as this. Is our knowledge of objects in the external world, is it direct? That is, we get it right there immediately. Or is it mediated through something? Locke and a few others said the perceptual properties that we get, such as the color, the shape, the firmness, and so on, don't match up with the actual physical properties that cause them. This account rejects direct realism, which says that we see the actual object, not a representation of it. So presumably, any thorough account of the properties of an object is going to have to include these causal powers or measures of some causal efficacy it possesses. How do we go about doing that? So without attempting to settle the problem, it's sufficient to ask how the external world could be represented to us. So think of water, if you would, please. We can see water as a solid, as a liquid, as a gas. And if we generally employ this, the real world is felt as if it has certain properties. In 1986, a guy named Frank Jackson wrote an essay called What Mary Didn't Know. And he suggested that Mary didn't know the experience of color until she saw it, despite a lifetime of learning about physical properties of light or color perception. So imagine this woman sitting in a very gray room, and she's studying color. She knows everything about color, but she's never actually experienced it. and then she gets to leave this room. So Jackson reasoned that if physicalism is true, that is, if everything is physical, then to know everything physically the case about something is to know everything that is knowable. But physicalism is false because Mary knows everything that's physically the case about light and about color, but she doesn't know what it's like to see color until she leaves her isolation chamber. One counterargument is that in the light of the day, Mary does not come to know something about light, but rather she experiences it just because she's exposed to certain stimuli. A guy named Lewis comes along, and he's more interested in what he calls qualia. Think of them just as qualities or features, okay? So qualia experiences capture how it appears to us. Let's see, I don't seem to have a quarter around here, but I do have a coaster. Now, from this perspective, the coaster is round. If I turn it this way, the coaster is flat, it's a line. If I turn it kind of this way, now it's an ellipse, okay? But ultimately, my brain knows that that is a round object, not a rectangular one, not an elliptical one. How am I able to do that? The decisive mark of this mental reality is consciousness itself. This is kind of the theater within which all of these qualia are featured. We might regard the conscious as the problem to solve in philosophy of mind. If there is some solution available, at least in principle, possibly from the realm of science, science isn't expected to disprove that we have experiences, thoughts, motivations, feelings, desires, and the rest, but it should establish either the causal factors of these mental states or permit the conclusion that these states that have been a long time described in mentalistic terms are actually just physical states passing in the brain. Huxley, who you may recall from our discussion of Matthew Arnold, had epiphenomenalism, okay? This offers a possible solution to the problem of consciousness, that mental states are just the byproducts of complex operations taking place in the nervous system. So if you're elated, you're happy, or you're depressed, you're sad, these might just be byproducts of things going on. Consciousness itself then comes out of these operations of the nervous system, but it doesn't necessarily have an effect on them. Epiphenomenalism gives more vitality to this question of what is a consciousness good for? What is its fundamental purpose? It might seem incredible to think human life could have amassed the same record without consciousness, but it's not logically impossible either. So credible or not, epiphenomenalism doesn't do the work that we need for monistic materialism. To grant that there are actual mental states distinguishable from any and all mental states kind of concedes dualism, says, yeah, there got to be two different things. And so one way that we might approach this is what we call identity theory. The first step to this is we start with qualia terms like red or melodic, okay? The question is, in reality, what do these terms really refer to? And the answer is, all these terms just refer to states or events in the brain. I identify red as being between this and this spectrum on the visible light spectrum, so many nanometers and so on. Melodic is how it sounds to me. So this doesn't confer infallibility on us. It also doesn't rule out self-deception. I could potentially be wrong. But it does put a dividing line now between the epistemic standing of any third-party report and that of the first-person report. What if you and I go to the Lowe's and we're standing there before the wall of paint chips and we have to decide on which is the most red they've got? What are we going to base that on? We don't have the perceptual equipment to see visible light spectrum in nanometer measurements. And so it's going to be kind of an educated guess at best. In its most interesting and most extreme form, this gives rise to what we call eliminative materialism. This says science doesn't need to worry about explaining the mental because there really aren't minds as such, and there really isn't anything mental to be explained. So we start to get into reductionist strategies. How do we get from the mental to the physical? But philosophy of mind offers alternatives to brains and neural events also. Any number of animals succeed in negotiating challenges afforded by the environment with nervous systems that are very, very different from ours. What matters is that a given function is performed in such a manner that it yields adaptive success suited for a particular environment. That is, that we're able to survive, and so are they. This is kind of translating the mental into a set of functions. If we take the position that actions are of any complex system, myself, my German Shepherd, whatever, are goal-oriented, based on felt experiences, motives, and feelings. I look at the functional components of these things, and the functionalist might just kind of put mentality on hold. One version of functionalism that gets a lot of attention is found in fields like artificial intelligence, expert systems. IBM had a chess-playing computer that defeated Garry Kasparov, one of the greatest chess masters of our age, in 1997. What's philosophically interesting about this outcome is not that computers can outperform human beings, but that the performance suggests the best understanding of our own mental operations is computational. This kind of goes back to Alan Turing. There are sound philosophical and conceptual reasons for caution here, because it's scarcely clear that a computer can play chess, or that it can play any game at all, or that it can, in any real sense, have the cultural resources to recognize that activity as a game. When you are playing your video games or whatever, the opponent, the AI, isn't playing against you. It doesn't feel any thrill of victory when it wins. It's running through an algorithm. It's only play for you, for the system, it's work. But imagine if, in some defensible respects, computers were intelligent, if they had expert judgment, if they could see the world even more clearly than their human inventors. Now we kind of get into Blade Runner territory. None of the issues in philosophy of mind would be settled, because now the same issues would arise with regard to the mental lives of computers. So you can kind of see this doesn't get any easier. In fact, it just gets more complex. And as we search for better answers, usually we just wind up coming up with more and different questions. This has been our last lecture together. I want to thank you all for how well you have adapted to this very sudden shift in the way that we're having to present our instruction. You've all done remarkably well. It has been an honor for me to be your philosophy professor. I hope you'll consider signing for future courses, and I will see you in email. Y'all take care. Bye-bye.